No. So they use the weight of the water that goes into this tank down there, and at the very bottom is a propeller, and the whole thing fills up. And it's just a rope pulley system all the way back to the house.
Light up things so that people can at least see what's going on. It's quite dark on a dark day. All I have to do is slide this leather belt from the idler pulley to the fixed pulley. And when I do, you see that activates the main shaft. Now every machine has available to it power from the turbine. Of course, none of them should be running because I haven't turned any of them on. You know, they all have their own on and off lever, the slide belts to turn them on. If I want to make a hole, I run this up against it, and that'll drill a hole because it's turning. And then, if I want to take away material, first of all, I have to reverse direction. Here we go. I put my cutting tool against the turning materials, as you see, and it will cut away material. You see the little pieces coming off, because that's harder. Now, as you can tell, I can't, if I turn that real tight, that'll stall the machine. I can't cut a lot away at once. This is slow process. There's keyway. See? That's how you're going to lock it on the shaft. Thing is, to cut that, I need something that's going to go back and forth. A cutting tool like this would work. You know, if I could set it up. If I had a machine that went back and forth. So that's what this machine here does. It's called a shaper. And there you go. It's going back and forth over the material, and all I have to do is change the cutting tool, lock this in there, and then I can cut that. So in the course of the day, I expect that cutting tool to be moving across the surface that way. In this case, the cutting tool is remaining stationary, and the gear I have in here is going to move through. Now, I don't have it set up to move, but, you know, you cut the teeth this way. Here, on the other type of gear that you're looking at, here's a couple of passes. That's why it's so slow. You can't take it away all at once. That was done on this machine. I have all cutting tools available to me to cut different types of gears that I can put in here. So it's very versatile. Now, as you know, I'm sure you can figure out that making a gear, the critical right here in Wilmington, Delaware, in 1869. It's a very versatile, very large steel craft. I can move the bit over the material. The table, of course, is adjustable up and down, and I can swing the arm over the material. Also, this machine, like most of them, has stepped pulleys down the drive pulley down here. It has 4 levels, and they correspond to the 4 levels of air. And that's to change the speed of the drill, depending on the kind of work I do. Now, it's cumbersome, though. I have to turn the machine on, send my apprentice up a ladder. We have to wrestle the belt off one onto another, rebase the belt. The whole time I'm doing that, I'm not getting any work. So I want to show you a 19th century innovation. This drill, 1890s here, is being run by a cone drive. And you see, the upper cone is always spinning, energized, from the main shaft. But the lower cone, which drives the drill, is not moving. To activate the drill, I squeeze the cones together, and the contact point between the cones, made with this leather belt, spins the lower cone. But look at what I can do. I'm able to change the contact point of the leather belt by moving. In this case, I'm moving to the left. Oh boy, that speeds my drill. And then if I move it to the right, it slows my drill down. Now I'm changing changing the drive ratio between the cones. Instead of steps on the pulley, I've got these different contacts.
It's called continuously variable.
And it's infinitely variable, like the trigger when I'm doing that. Pick any speed. I'm standing on the floor. The length of the blade itself is pretty impressive, but my theme is innovation, 19th century. You're going to see the top technology in the machine shop in the 19th century. I want to point out that this lathe is being powered by two drive wheels up here from the main shaft. Neither of them are engaged yet. The far wheel is on a twisted belt. You notice it's turning counterclockwise. The near wheel is on a straight belt. You notice it's turning clockwise. Now the innovation is this lever is attached to that bar, which activates an internal clutch in those wheels and enables me to select one or the other. I'm going to select the far wheel, and when I do, my lathe turns in counterclockwise direction. Now you can see what's coming. If I select the near wheel, my lathe turns in a clockwise direction. So I have complete control of the direction of my material here on the floor, fingertip control. I don't go up any ladders and move belts, twist belts, anything like that. It's like, a forward and reverse switch on the electric motor. Now I have one more machine to show you. It's fun to watch. That's this planer. Slide the belt and watch the top here. Watch what happens. When it hits that, slide the belt over. With different drive wheel and reverses the direction of the planer. Here we go. Slide it over. Now we're cutting. And then we have to come back for another pass. It's also semi-automatic. It's set to move across the material.
Jeez.
That's the cutting stroke, we can call that, or cutting direction. And here we go. That's me. Now at this point, in my guidebook, it says I'm supposed to.
Ava, he says that the turbine down there is about 45 horsepower. And it turns the rope pulley, and it comes right inside here. Call mommy. And it can drive all these machines.